Hello grade 12 and welcome to our first video in our series on the Doppler effect. Now before we start with the definition, I just quickly want to illustrate what the Doppler effect is. The Doppler effect is the change in frequency or pitch of sound. That is when a sound goes from a higher to a lower sound or from a lower to a higher sound. So it is this effect, that effect. And this is only detected by the listener. If you look at the car did not change its frequency, but as soon as the car passed the listener, it sounded to the listener as if the frequency changed. And this will only happen when the sound source is standing still and the listener moving, or the listener is standing still and the sound source is moving, or if both of them are moving relative to each other. So that's the last part of the definition. The sound source and the listener have different velocities relative to the medium of the sound propagation. So let's have a look at this definition again. Change in frequency of the sound detected by the listener when the sound source and the listener have different velocities relative to the medium of the sound propagation. It means they've got different velocities in most cases relative to the air, because in most cases the sound will be traveling in the air. Okay, now before we continue with the Doppler effect, we just need to do a little bit of revision on a few equations that we dealt with in grade 10. So the first thing that we look at is the definition of wavelength. Wavelength is the distance between two successive points in phase. Points in phase on a wave is the points that are moving, that's kind of making the same kind of movement all the time. So if you look here, these 2 points are in phase, because as time continues, both of them will move up. This one moves up and that one will move up, and then it will come down. These 2 points are not in phase, because as this one moves up, as time continues, this one will move down. Okay, so it's 2 points that has the exact same motion, and of 2 of them that are right next to each other, that is what successive means. The distance between them, that would be a wavelength. Okay, now this is the sinus wave. We know that sound is a longitudinal wave. And what is the difference again? A longitudinal wave is the motion that causes the wave is parallel to the direction in which the wave moves, or in which the waves propagate. So there I have a compression and a compression in my wave, and the distance between 2 compressions right next to each other, that will be my wavelength. Okay, let's look at the next definition. Frequency is the number of waves that follow per second, and period is the time it takes for one wave. So if I have a frequency of 7 Hertz, it means in 1 second 7 waves are going to pass. Okay, and then we know the time that it's going to take for those waves is going to be 1/7 of a second, because 7 of them fit in a second. So can you see there's a relationship between the frequency and the period of a wave? Let's look at our next definition, our wave equation. The velocity of a wave is equal to the frequency times the wavelength. If we look at those in units, the units for speed is meters per second. The unit for frequency is per second. And the unit for wavelength is meter. So can you see meters per second is just equal to meters per second, so that makes complete sense. We just said that there's a relationship between the frequency and the period of the wave. T over here is the period of the wave. Frequency is per second is equal to 1 over period. So if we say the frequency of the wave is 2 Hertz, it means that 2 waves would fit into 1 second. That means it would take half a second for one wave. So it's 1 over 2. So you can see it makes complete sense. So why don't you try these 4 questions on your own And then later I will post a second video with the answers for these questions, and we will continue the Doppler effect. This video is mainly revision for grade 10. And I've found in some of the recent papers, if you don't have a good grip on the grade 10 work, you might find completely lost in the Doppler effect, which generally is quite an easy question. So please try and complete this, and the next video will follow.